Next, we're taking a look at what are called relative maximums or relative minimums, and it's a turning point on a graph. So relative minimum would be a function that might curve a little bit, and the minimum would be a low point. Now this is called a relative minimum because for my example, the graph does continue to decrease, so it's not an absolute minimum. There are y values lower than that point, but it changes from decreasing to increasing at that point on the graph. Relative maximum would be a hill instead of a valley. So it's a point where the graph turns, it goes from increasing to decreasing. So now we're going to take a look at how to identify where our function is increasing or decreasing and where it's constant. And after we do that, we're going to find the points where it has a relative max or a relative min. So for this function, if we start with where it is increasing, of course, if you're going from left to right and tracing the graph and it's moving up, that would be where it's increasing. So because of the arrow on the end of this graph again, it starts its increase at negative infinity and goes up to, and we look at the x values when we're talking about where the function is increasing. For what x values does our graph increase? So this is an x value of -4. And at -4, it is no longer increasing. That is where it turns. So when we talk about intervals along which the graph is increasing, decreasing, or constant, those points where it changes are never included. The rest of the graph, there are no more increases, so we're going to move on to decreasing. Again, tracing the graph from left to right, notice it starts decreasing at x equals +4 this time, and it continues to decrease forever. And finally, where is our function constant? Constant is when it's not increasing or decreasing, so it would be a horizontal line. So we see a constant function between -4 and 4. Even for the constant function, those boundaries where it changes from increasing to constant and from constant to decreasing are not included in that solution. To clarify, this is not an ordered pair. It is in interval notation. So another way to represent this with inequality notation would be x is between -4 and 4. Identifying those relative max or min. In this case, there's no point where the function changes from decreasing back to increasing, so we have no relative min. And because the function is constant, where it changes from increasing to constant, those look like they might be relative max, but because the function is constant between them, we actually don't have any relative maximum on this graph either. So for this function, when we trace it from left to right, the entire time we trace it, our pen is going down. So our entire function is decreasing from -infinity to +infinity. Which also means we have no relative max or min on this function. All right, so on this one, we'll get to practice with some of our relative maximum and minimum. So tracing our graph from left to right, we're going down from -infinity to the x value of -3. Remember, all of this is in terms of the x. So the y value is irrelevant. The graph is decreasing from the smallest x value possible up to an x value of -3. After that, our graph turns and starts increasing until we get to an x value of 5, so between -3 and 5. Again, this is not an ordered pair. This is the interval notation saying as x is traveling between the values of -3 and 5, our function is increasing. And of course, we see that last piece where it's a horizontal line. So our graph is constant from 5, and the arrow means continuing until infinity. So we did have a point where the graph turned from decreasing to increasing. So you can visually see that this is a relative minimum. And because the function did not change to be decreasing again, it stayed constant, we have no relative maximum.